Um, when it comes to concavity, it's simple when you see the concavity on the diagram. Okay? You will know, okay, from negative infinity until my point of inflation, I'm actually going to get concave down. It's visible on the diagram. Right? Because you have your point of inflation. Remember, your point of inflation is where your concavity will change. So when you look at it this way, you will see, no, this is my concave down. My cap is looking down. Okay? Yes. And they say my point of inflation is at x equals to 0. Again, do you see how I'm also writing it? I'm going to say, for the graph to be concave down, then my x must be between what? My x must come from negative infinity until it gets to 0. And now, from 0 to infinity, the graph is actually concave up. Again, so the graph is divided into two parts, the concave up and the concave down. Where is the concavity starting? The guys who separated the concavity is actually the point of inflation. Understand? Now let me take my second derivative for this function was actually 6x, ne? I want us to check something. I want us to take all the values that are less than 0. This side. All the values that are less than 0. Any value. You can pick any value.
-2.
It's -2. Let me pick any value that is less than 0 and put it here. I'm going to put the second derivative and put any value that is less than 0. It's giving me 6 multiplied by -2, which is now -12. Again. So it means that now my second derivative will be less than 0 when x is less than -2. Remember. So what is happening when my second derivative is actually less than 0? My graph becomes concave down. You can also test it this side. When you are point of concavity, again what I'm saying is our concave up. Let's pick any value that is greater than 0. It's going to be? You can take 4. It's giving us 24. Again. Now we look at the sign. The value doesn't matter. We look at the sign. If you look at this side, the second derivative is actually greater than 0. So it means that from now on, even if you don't have the graph, but you have the second derivative or the first derivative or the function, you will know that now if I take any value and I substitute in my equation of my second derivative and my answer is positive, I know that will give me a concave up. It means my graph is still concave up. That's concavity. So what must you do in terms of concavity? That's how it works. You still want to write this down. I get why your concavity will actually change here. Again, when the second derivative is equal to 0, that is where the concavity will change, right? Again, so it means if it was concave up, it will now be concave down. Again, so if this was down, then it means after this point it will be up. So if my concavity was down, let me do this. It's going to be like this. I give it. It will be something along these lines. Already, if I know that I have a concave down, point of inflation, concave up, already you are giving me the shape of the graph. You're actually telling me what this is the shape of the graph. But if somebody can also come with a different notions to say, alright, Menier, but this one will actually be this one will actually, let me say, this is your point of inflation. And we have up and we have down. In your brain is to start saying, all right, I'm going to have something along these lines. So you get the shape of the graph. So that you will know what now. Here, my A is less than 0. And this side, my A is greater than 0. So you know the value, the sign of the value of A. Then you'll be able to know how to deal with that, your concavity of the graph. But once you have the graph, it's easy for you to interpret from the graph. So we're talking in a sense of you're not giving the graph. Ramon. Isha.
Yes.
And